Welcome once again. I'm always happy to come your way because I'm excited leading you to the promised land. And that is the main focus of LearnRite. We are still on covalent bonds. In our last video, I explained how covalent bonds are formed. But of course, we only explained how single bonds are formed. Today we are going to go further than that. We are saying that covalent bonding is about sharing. Just as when you are in your house or even in school. Let me use the school examples. Someone just quickly go and bring the gari, you also go and bring water, and then the person who usually doesn't want to contribute to anything will bring bowls in the school and say, I have the bowl. But you know, you're all sharing something, and then you enjoy the gari soakings together, or the gari photo or whatever together. So covalent bond is purely about atoms coming together to share electrons. Atoms come together to share electrons. If they share one electron, of course you have one bond formed. But they can share more than one electron. So today we are going to see how atoms can share more than one electrons, okay, to form more than one bond. So going ahead, let me take a compound like methane. Methane is carbon H4. One carbon going to form bond with 4 hydrogen atoms. Let's see it well. What is the nature of carbon? Carbon is 6 atoms. So in terms of electronic configuration, using the shell, we have K2 and then L what? 4. Or if you use the detailed one, we have 1s2, 2s2, 2p, 2. So you see that carbon from here, we need 4 electrons to form its octet. Or even from this detailed electronic configuration, you see that carbon, if it has 2 electrons in the p, before it can fill the whole of the p can take 6, so it still needs 4 electrons to fill the p orbitals. Hydrogen is always 1. It has 1s1, or we say it is k1, which means that if you are using the k shell type of electronic configuration, it needs 1 more electron to fill the duplet. And if you are using the detailed electronic configuration, it still needs 1 more electron to fill the only orbital available to it, that is the 1s orbital. So carbon will always form, hydrogen, no matter what, will always form one bond. Are you seeing that from here? Hydrogen has 1 electron, it needs only 1 electron to form its duplet, so it will always form one bond. But carbon needs 4 electrons to form its octet, so carbon can form 4 bonds. So let's see how they form the bond. Hydrogen carbon, let me just draw it straight away. The 2 electrons are here. The 4 electrons are there. So it will form bonds with 4 hydrogen atoms. Four of these hydrogen atoms will come and combine with only 1 of this. The result will be this. You have the carbon let me draw it well. Forgive me, my diagrams. So you have the nucleus, of course, would have had the 2 inner, we have the 2 electrons within the shell of the carbon existing there, but it's the outside one that is forming the bond. So we have 2 electrons here. From this hydrogen, you have 2 electrons there, 2 electrons there. This is 1 hydrogen, this is 1 hydrogen, and that is another hydrogen. This is the carbon with a nucleus in the middle. So one carbon atom combining with 4 hydrogen atoms. So the hydrogen atoms, the nucleus will be in the middle. It will still be there. Each hydrogen atom will still hold on. The nucleus will still hold on to that electron. Don't forget. Now that carbon has contributed another electron there, it will look as if this electron will also be held by the nucleus of the carbon. This hydrogen here will be held by the nucleus of the carbon. But in all the 4, carbon will still hold the electron that it contributed to its nucleus. Hydrogen will hold its electron that it contributed to its nucleus. In all, if you look at this carbon, the carbon in here will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So it is satisfied. It has completed its duplet, fully fold electronic configuration. Each hydrogen atom also assume these 2 electrons. So this hydrogen is satisfied, that hydrogen is satisfied, that hydrogen is satisfied, and that one is also satisfied. So in simple terms, we look at this structure here as being carbon, hydrogen bond, that is electron pair, hydrogen bond, hydrogen bond, hydrogen bond. Are there any non-bonding electrons in this structure? Do you have any electron pair in this structure? I guess you see, as I can see, that there is none, because the 4 electrons available to carbon in the atom shell, carbon has contributed all in the sharing with 4 hydrogen atoms. So we have this 1, 2, 3, 4, each dash here representing 2 pair of electrons, which you call the bonding pair electrons. So we have 1, 2, 3, 4, representing 8 electrons in all. Hydrogen assumes these 2 electrons on its own and it's fully filled. That hydrogen the same. Carbon assumes this electron pair, that, and that, making it 8. And that is also fully a full electronic configuration. In simple terms, I'm only telling you that a particular atom can form 1, 2, 3, or 4 bonds, depending on the number of electrons that it is required to fill its duplet or octet. Depending on the number of electrons that an atom requires to fill its octet or duplet, it will form the bond. It will go and share. If I need 3 more electrons to fill my octet, I need to go and share 3 electrons. If I need 2, I'll go and share 2 electrons. If I need 1, I'll share only 1. This structure that we have shown in terms of bonding, students, this is how it looks like. What I've done on the board is not a structure. This is full structure of methane. Carbon is always black in the middle. These are our hydrogen atoms. The dashes in between them, the bonds, represent the electron pairs. In this case here, there is no lone pair electron or non-bonding electrons in any of the atoms. So that is the structure of methane. C, that is carbon, H4, hydrogen, 4 atoms. And we have seen the bonds. You see that, if you look at this, you see that if I turn it anyway, I get the same structure. If I turn it anyway, I get the same structure. That is actually not what I drew on the board. What I drew on the board would have been something like a plus, like horizontal like that, but that is not what really I've drawn on the board. Now, this form, if you want to draw the structure itself, you could give your carbon so that it will reflect what the structure is. Usually, some of us who cannot draw very well, we are not able to draw in 3 dimensions for you to see it correctly. But in this organization, LearnRite, we show you the actual picture of everything. Okay, no 2-dimensional, no gimmicks about it. This is the actual structure of methane. Carbon in the middle, 1, 2, 3, 4. Anyhow you turn it, you get the same shape or the same structure. This is called a tetrahedral structure. Don't be in a hurry. The next major topic that we shall be treating after bonding will explain the structure of almost every compound for you. So this is called tetrahedral structure, and that's the structure of methane. This is telling us that any atom can form more than 1 bond depending on the number of electrons that it requires to complete its duplet or octet. If I go ahead and show you some more bonds, this will be the structure of ammonia. Ammonia is nitrogen, 3 hydrogen atoms. Nitrogen, the blue structure here, 3 hydrogen atoms forming 3 bonds. Why? Because go look at the periodic table, you see nitrogen in group 5. If it's in group 5, it needs 3 more electrons to fill its octet. So nitrogen will share 3 bonds, will share 3 electrons, and the octet will be filled. This is water. This is water. Hydrogen, hydrogen, and then oxygen. Oxygen needs 2 electrons to fill its octet because it is in group 6. Let me go to the board and show it very well. From what we have illustrated so far, I want to summarize by telling you that covalent bonds are formed mainly by the nonmetals, starting from group 4 onwards. The bonds are formed among themselves. Okay, you take a group 4 with any other atom there, or with hydrogen. So from group 4 here, sometimes of course the group 3 boron can also form covalent bonds, but normally they are formed by the nonmetals. Group 4 will always form 4 bonds. Why? Because in group 4, being in group 4, you need 4 more electrons to fill the octet. So any group 4 atom in forming covalent bonds will form 4 bonds. It will go and share 4 electrons, and after doing that, its octet will have been filled to become stabilized. A group 5 element, nitrogen, phosphorus, astatine, they all form 3 bonds. Why? Because they need 3 more electrons to fill their octet. Group 6, being here, needs 2 more electrons to assume the octet state. So any group 6 element will also form 2 covalent bonds. And that is why you always find oxygen forming 2 covalent bonds with hydrogen, in the case of water, for instance. So oxygen will form 2 bonds. And then all the halogens, that is the group 7 element, will also form only 1 bond. They will share 1 electron to form 1 bond at a time, so that their octet will be filled. In going forward, going ahead, if you take water, now I think that we are grown, so I'm just going to use the valence share electrons to form the bonds. In water, for instance, how is the bond formed? It is formed between oxygen. Remember that if I write oxygen, how many electrons will oxygen have in the atom shell? It will have 6 electrons. Oxygen 8 is K2L6. Okay, that will give us 8. So if it is 8, how many electrons do we need to fill the S shell? 2. So oxygen needs 2 more electrons. So for oxygen forming bonds, it will be like this. Oxygen will have 6 electrons in the atom shell. It will only share 2. So it will share 1 with this hydrogen, that has 1, and then another 1 with this hydrogen, that has 1. So this will share, that will share to form a bond. So hydrogen will now assume the duplex state. This hydrogen will assume the duplex state, and this oxygen will assume the octet state. So oxygen will be 1, 2, 3, 4, 5, 6, 7, 8. Let me count them again. 1, 2, 3, 4, 5, 6, 7, 8. So every water molecule is indicated as this. Then oxygen will have 4 non-bonding electrons. In terms of pairs, it will have 2 lone pair electrons. Look at it. We have formed a bond with this. So this is gone. We have formed a bond with this. This is gone. How many electrons are left with oxygen in the atom shell? 1, 2, 3, 4. So they are here, arranged in pairs. So this is 1 lone pair. That is another lone pair. So water is a molecule where oxygen is bonded to hydrogen to form 2 bonds, and we have 2 lone pair of electrons. That is that. Now again here, I'm showing this angle because when we come to the actual structure, you see that that is the actual structure of water. And that is what I have here represented nicely. You don't have any of these in any of your classroom. These structures, it is only LearnRite that can show it to you. Okay, that is it. So the red is always the oxygen, the small white ball representing hydrogen. In actual fact, around this oxygen red here, we should have our lone pair of electrons showing, but we cannot show it in this ball. So that is it. That's the structure. So oxygen, a group 6 element, is forming 2 bonds. It has shared 2 electrons. The remaining 4 electrons there arranged in pairs are said to be 2 lone pair of electrons on oxygen. On oxygen. Later, we can use this electron to form more bonds, and the bonds will be named differently. I'll show it to you very soon. Don't worry, in our coming videos. This is another molecule. If my carbon is represented by this black ball, and I just show you that my oxygen is this red ball. Now look at this structure that I have here. If I hold this structure, carbon in group 4, how many bonds will it form? It will only form 4 bonds, isn't it? And oxygen in group 6, how many bonds does it form? It will only form 2 bonds. So you see it here, this carbon here has the black, the carbon here which is black is bonding to oxygen which is red. Oxygen needs 2 bonds, and that is the bond, this and that. 1, 2 for oxygen. This oxygen also needs 2 bonds. 1, 2. So this oxygen is fully filled. Sorry, is fully. It has completed its octet. This oxygen has completed its octet, and this carbon needs 4 bonds because it is in group 4. And so for the 4 bonds, we have 1, 2, 3, and 4. If I want to put it on the board, I'll just indicate it as this: carbon with oxygen with oxygen. How did we get this? Let's look at it. Oxygen has the 6 electrons in the outermost shell. Carbon has the 4 electrons in the outermost shell. As for oxygen, don't forget I've shown it here. It's 8 electrons. 2 electrons in the K shell in the inner shell, that doesn't form bonding. 6 electrons in the outermost shell, that is the L shell. Or if I say want to expand this, I'll say 1s2, 2s2, 2p4. 2p4. So this is 2, this is 2. The principal quantum number being 2, that is the outer shell. So if you have the outer shell, then you have 6 electrons in them. These are the 6 electrons. In terms of orbitals, they are located in the s and the p orbital. So we have 2 electrons required by oxygen to complete the bonds. When it comes to carbon, we have 4 electrons for it to complete. To complete its octet, please note on board. We have 4. We need 2 electrons to complete the octet for oxygen. We need 4 electrons to complete the octet for carbon. Carbon would therefore have this structure: 4 electrons in the outermost shell. So what happens? Carbon, the first bond will be here. The second bond would form with this. So this oxygen would have been complete. So if this is the electron, that is the electron initially belonging to them. Carbon will donate this. Sorry, oxygen will donate this electron. Carbon donates this electron. They share. They form one bond. Again, this carbon donates this electron. This oxygen donates this electron. They have formed this bond. Oxygen becomes full. It tells you, look, I'm now fully filled. My duplet is filled, so I cannot form any more bond. Carbon has now formed 1, 2, 3, 4, 5, 6 electrons. It is still not fully filled in terms of duplet. So carbon will still go ahead and look for another friend to form more bonds with, so that its duplet can be filled. So there will be another oxygen lying here, which will also have the 6 electrons in its outermost shell. So in this case, carbon comes to form another bond with this, and then another bond with that. So when they form that bond, when they share those electrons, this oxygen again will be 8. This oxygen will assume this electron that belongs to it, sharing with this, that is 2. This electron that belongs to it, sharing with this, that will be 4. Plus 1, 2, 3, 4, making it 8. So oxygen has filled its octet. It's fully filled. It is now happy. And then if you look at carbon, carbon now will also be fully filled within the outer shell, because carbon will now would have shared its 4 electrons that existed in this outermost shell. So this carbon now has carbon 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this is what you get as here. So if you get this one here, it means this oxygen will still have its lone pair of electrons. This oxygen will have its lone pair of electrons. 2 each. Carbon doesn't have any more lone pair. Carbon doesn't have any lone pair. It has shared all the available valence electrons. So that becomes the structure of carbon dioxide, or what we say, carbon 4 oxide. And that is it. That's the structure. Carbon forming 2 bonds here with oxygen. Oxygen becomes fully filled electronic configuration. Carbon form another 2 bonds here. This oxygen becomes fully filled. Then the carbon is also fully filled. So the summary is all group 4 elements can form 4 bonds. No lone pair electron or no non-bonding electron available to them. Group 5 can only form 3 electrons. They can form 3 bonds by sharing 3 electrons. How many electrons do they have in the atomos shell? Group 5 will have 5 electrons in the atomos shell. That is why they are called group 5. So when they share the 3, they will have with 2 electrons, 2 non-bonding electrons. So any group 5 element forms 3 bonds, and to be left with 1 lone pair or 2 non-bonding electrons. Remember, we have said that non-bonding electrons, if you put any 2 together, it gives you 1 lone pair or 1 non-bonding pair. So group 4, no lone pair. After forming the 4 bonds, it will have shared all its 4 electrons available to it. Group 5 will form 3 bonds by sharing 3 electrons. It is called group 5 because it has 5 electrons in the atomos shell. So how many bonds? How many electrons will be left? 2, and this will be put together as a 1 lone pair electron. Group 6 will always form 2 bonds by sharing 2 electrons. It is called group 6 because it has 6 electrons in the atomos shell. So after sharing the 2 electrons to complete its octet, it will have 4 electrons in the atomos shell, which put together will be called 2 lone pair electrons. 2 lone pair electrons. Group 7 is called group 7 because it has 7 electrons in the atomos shell. What does that mean? It means it needs only 1 more electron. So it goes ahead to share only 1 electron. And after sharing that 1 electron, it will be fully filled. And it will have 6 electrons in the atomos shell, which put together in pairs will be said to be 3 lone pair electrons. 3 lone pair electrons. So let me quickly summarize it here. Group 4, 4 bonds. They form 4 bonds. No lone pair electrons. No lone pair electrons. Group 5 will form 3 bonds. It will have 1 lone pair electrons. Group 6, 2 bonds, 2 lone pair electrons. And then group 7 will form 1 bond. And we'll have 3 lone pair electrons. That is the summary. And so we conclude by saying that covalent bonds are formed by the nonmetals. It does not mean that other elements do not form covalent bonds. Boron, a group 3 element, mainly form covalent bonds. I will explain in hybridization, our next major topic, how and why boron forms covalent bonds. It's a metal. It's regarded. You see, look at the colors. When we're talking about the periodic table, I told that boron, though here it is expected to be a metal, it is put among the metalloids because sometimes it behaves as a metal, other times it behaves as a non-metal. But when it comes to bonding, almost all its bonding are covalent bonds. Look at the colors here. This color is the blue color, light blue color here indicates the non-metals. Okay, and these are the metalloids, semi-metals, and these are the non-metals. Okay, so covalent bonds are formed by the non-metals mainly, or semi-metals. They form covalent bonds with themselves and of course with hydrogen. They can form that bond with hydrogen. So this is telling us that when we're treating ionic bond, we saw that we use hydrogen to form ionic bonds, where hydrogen hydrogen will lose the electron to the metal, the group 1, group 2 metals. So hydrogen is able to form an ionic bond. At the same time, it forms a covalent bond. In fact, most of its bonds are covalent. Most of hydrogen, the bonds that hydrogen forms are covalent because it has one electron. The metals are cheese when they come, they just switch the metal from, they switch the electron from hydrogen, and hydrogen becomes negative. But then later they form that electrostatic force of attraction, making that bond become ionic. Apart from the bond between hydrogen and these metals, that is ionic, all other bonds of hydrogen are covalent. All other bonds of hydrogen are covalent. Okay? So hydrogen and the nonmetals form the covalent bonds. And covalent bonds, a particular atom can form 1, 2, 3, or 4 bonds. And this depends on the number of electrons left for that atom to complete its octet or duplet. So we have seen the bonds. We have seen examples of them. Now, having shown you examples of these molecules, I have on the table here a number of natural substances that are formed because of covalent bonds existing in them. A number of them. I have sugar. This is sugar, very sweet. Okay? The bonds in the atoms of sugar are all covalent. This is water in the glass. I showed you how water is formed. This is water in the glass. The molecules, the water molecules in this water substance that we see are all covalent bonds. This is plastic. Plastic is made up of carbon, hydrogen atoms. Organic chemists, when we come, they will treat it. And every bond here is covalent. That is oil. The fritol, oil that you use in your home. In organic chemistry, we call it a triglyceride. It is, every bond there is also covalent. And that is silica. Silica, the POP cement, or when you break your leg, when you go to hospital, the one that they mix water with and form POP. That is silica, SiO2. That is also covalent. Silica is SiO2. I'll come to it very soon. I'll come to explain the chemistry behind this very soon. The bond there are all covalent. The pencil that you see, the black thing that is in the pencil, that when you scribble on the paper, it appears. It is called graphite. Graphite is basically carbon bonded to each other throughout. Only carbon. Carbon bonded to each other throughout. And that graphite is also covalent. The bond between each carbon atom in the graphite is covalent. So this graphite here, that black thing in the pencil called graphite, is purely carbon bonded to each other in a certain structure. That is graphite. The spelling is graphite. So these are several examples given to you. In fact, most of the substances that we have in nature, in my own view, most of it will be covalently bonded. Because look at the elements. All this bonding with each other. Lots of them. And we have almost all the organic compounds that we have in nature. Plenty of them. Countless of them. The bonds between the atoms of almost all organic compounds are covalent bonds. So I'll end here, come back and continue. I've used these 2 videos to explain the nature and formation of covalent bonds. We want to move on. We move on to the units that we can see at the latter site in our next video. Come with me. Thank you.